Hello everyone, welcome to Maths and Science Intervention Club. Today we're going to be doing rate. The rate, it is a measure of how rapidly one quantity changes in comparison to the other. So now with the rate, we are going to look for the speed, distance, and in time. So that is how we are going to look at the rate, right? Now with this particular rate, I'm going to start with the speed. Now before the speed, I'm going to give an idea of what I'm going to refer to. Let me just say this one, it is your home, and this one, it is the school, right? Your school. The distance from your home to the school, it is 30 kilometers. That is the distance from your home in school. The time, it is 7 a.m. and you are still at your home. By 7:30, you should be at school. Means the school starts 7:30, right? So this one is your home. This one is the school. My question is, what should the speed be so that you should be traveling with, so that exactly at 7:30 you are at your school? We know that there is a car. From a car, we have what is called the speedometer, right? Let me just say here 0 kilometers, 90 kilometers, 180, 90, 120. Let me just say I have a 60, right? Let me just say the speed limit, it is 180 kilometers. The question is, where should the speedometer point and what should the speed be so that exactly at 7:30 you are at your school, right? Given that you left your home at 7 a.m. So the formula for speed, we are going to have speed. It's given as distance divide by time. That is the formula for the speed, right? So I'm going to come, the distance should be in kilometers and the time should be in hours. That is why we have kilometers per hour, right? So that is, I'm going to have my speed equals to distance over time. The question is, what should the speed be so that exactly at 7:30 you are at the gates of your school? I'm going to start with the distance. What is the distance from your home to the school? The answer is 30. Is it in kilometers? Yes. It means I'm going to substitute that particular 30. I'm going to go with the time. How many minutes are you going to spend in the road from your home to your school? We are going to see that we are going to spend 30 minutes, right? But then here I cannot put 30. Why? Because it is in minutes and my time should be in hours. Therefore, it means I'm going to say 30 minutes. It is the same as how many hours? It means for me, when I move from minutes to hours, I have to divide by 60, right? And the answer becomes 1/2. It means here I'm going to have 1/2 or 0.5. Instead of me, I'm substituting the 30, but then I'll substitute the 0.5 or 1/2. And what is going to be 30 divided by 0.5? The answer is going to become 60 kilometers per hour. It means from the speedometer, right, my speed should be exactly here. It should point here so that exactly at 7:30 you are at the school gate if you leave your home at 7 a.m. and if the distance from your home to school, it is 30 kilometers, right? Now here's another question. It says if a car drives 200 kilometers in 2 hours, determine the speed. Determine the speed, right? So I'm going to use the formula for speed. Speed, it is the same as speed. It is equal to distance over time, right? Now I'm looking for the speed. I'm going to go and look for distance, right? Distance, it is always going to be in kilometers. Sometimes the distance can be in centimeters, it can be in meters, it can be in millimeters, it can be in miles. So these are the measurements of distance. And for the time, The time is always going to be in hours. You can have time in minutes. You can have time in seconds. You can have time in many different ways. Now let us look at this 200. This 200, it is attached to kilometers. When you say the kilometers, what representation can the kilometers represent? We know that the kilometer represents the distance, meaning this particular 200, since it is attached to kilometers, that particular 200 has to represent my distance. It means on the distance part, I have to substitute the 200, right? Now, this particular 2, it is attached to the hours, right? So hours is a representation of what? Hours, it is the representation of time. It means on the time part, I have to substitute the 2, right? It means my speed, it is going to be, what is 200 divided by 2? The answer is going to be 100 kilometers per hour. That is going to be my speed. It means my speed for this particular car, it is going to be 100 kilometers per hour, right? Now, so that is a calculation of speed, distance, and time. But then we have other method of calculating other things that do not require speed, distance, and time. For example, but then they require rate. I have a car. My car can travel 10 kilometers on every liter of fuel. Then how much petrol will I need for? Then we have A, 40 kilometers, we have B, 400 kilometers. Then we have, let me just say, and I add another question. I have 20 liters of fuel. How many kilometers can I drive for? That is the question. Now let us look at the first question, A. It means I have a car, right? Let me just draw a simulation. It's always safe to have a simulation of what it means, right? I have a car. This is my car. Now this car uses fuel, right? It means if I put 1 liter of fuel, so let's say this one is my fuel. If I put 1 liter of fuel into this car, 1 liter of fuel allows me to drive for 10 kilometers. It means if I put 2 liters of fuel, I'm going to move for 20 kilometers. If I put 3 liters of fuel, I'm going to move for 30 kilometers, right? But then if I want to move for 40 kilometers, how many liters should I put? That is my question. So we are going to establish the relationship between fuel and distance. It means here I'm going to have fuel in liters. I'm going to have distance in kilometers, right? I know that 1 liter of fuel allows me to drive for 10 kilometers. So it means every liter of fuel allows you to drive for 10 kilometers. But then if you want to drive for 40 kilometers, how many liters of fuel should you have? We are going to have X. Let us assume you don't know. We already know that the answer has to be 4 liters of fuel, but then let us assume you don't know and we want to find that 4. We have what is called cross multiplication, right? The number that is above on the left hand side will multiply the one that is below on the right hand side, and the one that is above on the right hand side will multiply the one that is below on the left hand side. It means the 1 and the 40, they will multiply each other. The X and the 10, they will multiply each other. It means I'm going to have what is 1 times 40. I'm going to have a 40, then I say equal to, and I'm going to have a 10 multiplying the X. I'm going to have a 10 times X, right? Then after having the 10 times X, I'm looking for X, right? If I'm looking for X, the problem here is this 10. What can I do from 10 to be left with X? I'm going to say that 10 and X, they are multiplying, right? So if they are multiplying, what is the inverse operation of multiplication? It is division. It means I'm going to divide both sides by 10. So the 10 and the 10 will remove each other, what will I be left with? I'm going to be left with x on the right hand side. And what is 40 divided by 10? I'm going to have 4, and the x represents the liters. It means I'm going to need 4 liters of fuel for me to drive for 40 kilometers as the distance. Now let us look at B. If I want to drive for 400 kilometers, how many liters of fuel should I have? Right, I'm going to establish the very same thing. I'm going to have fuel in liters. I'm going to have distance in kilometers, right? So my fuel, I know that 1 liter of fuel allows me to drive for 10 kilometers as my distance. But then if I want to drive for 400 kilometers, how many liters should I have? I'm going to put x over there. The number that is above multiplies the one that is below, and the one that is below multiplies the one that is above. It means the 1 and the 400 will multiply each other. It means I'm going to have 400 multiplied by 1, which is 400. Then I say equal to 10 multiplied by the x. I'm looking for x, not 10 times x, meaning I have to remove that particular 10 by operating the inverse operation, right? 10 and x, they're multiplying. It means I have to divide. It means I'm going to divide both sides by 10, divide both sides by 10. Therefore, it means 10 and 10, I'll be left with x, right? Now, if I'm left with x, it means I'm going to have what is 10 divided by 10? I'm left with x, and what is 400 divided by 10? The answer becomes 40. It means I'm going to need 40 liters of fuel for me to drive for 400 kilometers, right? So if I have 20 liters of fuel, that is C. If I have 20 liters of fuel, how many kilometers can I drive for, right? Using this same car, I'm going to have fuel in liters. I'm going to have distance in kilometers, right? I know that 1 liter of fuel allows me to drive for 10 kilometers as a distance. But then if I have 20 liters of fuel, meaning the 20 has to go into the category of fuel. If I have 20 liters of fuel, how many kilometers can I drive for? That is why I should have x on the part of fuel. The number that is above multiplies the one that is below, and the one that is below multiplies the one that is above. It means I'm going to have a 10 multiplying the 20. I'm going to have 200. Then I say equal to the x will multiply the 1. Any number multiplied by 1 is that number itself, meaning I'm going to have an x. It means I'm going to need, if I have 20 liters of fuel, I will drive for 200 kilometers. That's it. Thank you so much. I hope you enjoyed this lesson. Please don't forget to like, comment, and share. Please subscribe. Thank you.